I don't know if I should be excited or if I should stand back.
Hello Internet, my name is Quinn and this is Blondihacks. For the Barzy Summer Bash this year, Stan came to me and said, "Hey Quinn, I bet you can't drive the raffle drum with your steam engine." And I was like, hold my beer. Actually, no, that's not at all what happened. Stan was like, "Hey, do you think we can do this?" And I was like, that'll never work, because I'm a professional naysayer. But let's give it a shot. Careful what you wish for. A few days later, this beast arrived from Stan via Amazon. And this is a standard acrylic raffle ticket drum, normally hand cranked. And well, this is the Industrial Revolution, so let's see if we can steam power it. My first thought for how to do this is probably similar to what yours would be, which is to drill out the axles in this thing and replace them with my own and have some kind of sprocket or drive pulley or something mounted outboard. But the problem is that this thing is acrylic, and anything you try to do to it is going to be difficult to do without shattering it or cracking it or other shenanigans. So I think I'm going to try to drive it with the existing structure somehow. The good news is this thing actually has bearings in it, so it's surprisingly easy to turn when empty. Now I have to figure out how to drive it. My first thought was some sort of flat belt arrangement on the big outer wheel there on the side. So I mocked it up with tape to see how that would react, and this kind of worked, but the tape kept slipping down onto the hexagonal part of the drum, which actually gave me an idea. So then I got some cotton string, put that around the hexagonal portion itself, and then mocked that up with the roll of string itself. And this worked surprisingly well. Now, I wasn't sure if the hexagonal profile would be a problem, because that means the ideal length of the belt is actually changing as it rotates. The chord of a hexagon is not, of course, the same through the center all the way around. So my mill vise was handy, so I moved it over and kind of mocked it up with an axle in a constant position so I could see if that hexagonal profile was going to be a problem, and it really wasn't. This worked excellent. And I could get a sense from turning the spool by hand how much power was going to be needed to do this. The answer was surprisingly little. With such a small pulley leading to such a large one, it really didn't take any effort at all. So I was starting to get confident that maybe the steam engine can actually do this. I also wondered if some sort of belt tensioning might be necessary, like a spring-loaded arm or something, so I kind of got a sense of that with my finger, and honestly, this really didn't seem to be helping at all. I think it'll run just fine without a tensioner. The string has quite a bit of stretch in it, and that's really working in my favor here. Clearly I'm going to need some sort of pulley, so I found this chunk of Delrin in the scrap bin. It's the same diameter as that roll of string, since that seemed to be a good size. I'm literally making this up as I go along. So I dialed this in on the forejaw. Unfortunately, white Delrin is nearly impossible to photograph well, so apologies for the blinding white blob that will be the center of your screen here for a little while. Since I don't really know what kind of pulley I'm going to need, I just started with a round-nosed tool here. I'll try this string as my drive belt, since that seemed to be working well in the tests, and for that a U-shaped groove in the pulley should be just fine. So I found the edge of the part there, and I set up an indicator to move my carriage over the exact amount that I want to get the rough wall thickness on this pulley that I feel like is going to be okay. Again, just making this up as I go along. Now normally when I turn Delrin, I set up a shop vac like this, and this trick works super well because Delrin makes one long chip that immediately wraps itself around the chuck and makes a giant mess, so the vacuum works great. The long chip gets sucked into the vacuum as you turn. However, this form tool didn't have that behavior at all. Instead, it actually was breaking chips and throwing them all over the place, so the vacuum was kind of doing nothing in this case. I swear this trick normally works really well when turning Delrin normally, but it did make a handy disposal system for the chips after each operation. After eyeballing a decent depth on that groove, I switched to my center drill so I can put a hole through the center of this thing for the crankshaft on the steam engine. And I'm going to drill this slightly undersize and then ream it to 3/8, which is the diameter of that crankshaft. You might be thinking Delrin is a poor choice for a drive pulley, and it kind of is because it's very slippery. In fact, it makes quite a good bearing material in low-speed applications, but I'm using it here because it's extremely fast to machine, and I can prototype this idea in a hurry, and if it works and I need a better material, then I can make this again in a better material very quickly. And what you're seeing here is almost real time. I mean, this pulley took a couple of minutes to make start to finish, so Delrin is a great prototyping material because it's so fast and easy to machine. And Yahtzee. Quick deburr, you'll note that I actually didn't even bother facing this part on either side. The parting blade did a fine job on the back side, and the front side was already faced on the stock. Again, not too worried about appearance here. This is all a quick and dirty prototype. I still have no idea at this point if this is even going to work. But the pulley is a nice fit on the crankshaft there, so let's mock it up with the same test I did before and see how it works. So I've got kind of a bearing of sorts made from a scrap of aluminum that I put in the vise, and I put that around a scrap of drill rod. And this would not turn, I think, because the belt is too loose. So I made a new belt out of some slightly shorter string. I also decided to try a windlass arrangement like on a sailboat winch. So you do a double or triple wrap of the material around the pulley, which I think will help both with gripping on the slippy Delrin and should just transfer the torque better. And that's turning very well. And the other thing I like about this arrangement, it's kind of a happy accident, is that the weight of the drum is very off-center. It's very eccentric, and it'll be more so when the tickets are in it. And so this Delrin and windlass arrangement allows the drum to overrun the pulley as needed. So the engine can run at whatever RPM it wants to, and the velocity of the drum can vary a little bit without interfering with it. I'm becoming increasingly convinced that this might actually work, so over to the drill press to put a set screw in this thing. I'm doing this on the drill press because the mill is occupado at the moment, and I just eyeballed the center of this thing, and it doesn't really matter if it's perfect. So I drilled that tapping size for a set screw, and then I ran a tap down there. Because this is Delrin, I used a tap drill size a couple sizes smaller than I normally would, because Delrin is very, very stretchy, and I want it to grip really well on this set screw. Delrin doesn't necessarily hold a thread super well because it is plastic after all. Back to the engine for a test fit. Fits nicely on the crankshaft there. And I'll put my set screw in there. This is a basic dog point set screw. Full disclosure, I did end up filing a little flat spot on the crankshaft once I had established the location of this pulley. A little flat spot really helps keep the pulley from slipping, which it really wanted to do without that. Back over to the drum now with the double wrap of the string, and I just got to set the tension right, get it roughly straight. It looks like just turning the flywheel by hand here that this is going to work. So nothing to it but to put some air on there and give it the first real try. Okay, it's running, but the string is slipping, so let's add some tension to that belt, slide the engine back, and oh my gosh, there it goes. Would you look at that? That's only about 5 psi on the engine there right now, but the drum is empty and it's easy to turn, but wow, as a proof of concept, this is a raging success. So I think this is gonna work. I need a base next and a way to tension the belt, so I grabbed a scrap of wood and a piece of aluminum angle, which I cut to length. This aluminum angle is going to be used to mount the base of the engine to the ticket drum, and I'm also going to use it as the belt tensioning mechanism. I roughly marked some center holes with a punch, more or less centered. This is all going to be a one-time use thing. And the mounting holes were drilled on the drill press. For the tensioning slots, I need to use the mill, or rather I want to use the mill, but it currently has a very complicated setup on it for my boiler project, and this setup was a ton of work, and I don't want to touch it. However, using this spare vise I have, I can just sneak it in between the footstock and the rotary table setup there. And then I can get in there with a small end mill and mill out these slots. I was very glad to be able to do this, otherwise it was going to be chain drilling and filing like a chump. The corresponding mounting holes were then marked and drilled on the base plate. There is, of course, a giant knot in this piece of wood right where I want to put one of my mounting holes, but it doesn't seem like that's caused too much of a problem. It looks like that will hold. And now I got to line up the engine, so I'm just kind of squaring up the base where I want the engine to sit and marking the outline of it there. And then I can measure where those threaded inserts are and get those lined up. And then I drilled holes for that. And now I can screw that into the base with some 1/4-20 countersunk screws. And that is looking pretty good. So now let's get it lined up on the ticket drum there with the belt tensioning about right. And then I will mark the centers of the slots on the base of the drum there, and this will attach it to the drum. Now, I really hate drilling acrylic, but there's no choice, it's got to be done. So I started with a center drill on my marks, and then a small pilot drill. I'm going real easy and using light pressure to try and avoid chipping out the backs of the holes or creating cracks. There's probably some technique involving tape or something that prevents chipping when drilling acrylic, and I'm sure 58 people will put that in the comments, so rest assured I will know for next time. Let's do a little test mount here. I've got some wing nuts that I found in the drawer for the backs of these cap screws, and that will allow me to easily adjust the belt tension on site as needed. Okay, let's put some air on here and give it a test run. And look at that. That's kind of amazing. I'm honestly fairly shocked that this works at all, and honestly it really works quite well. Now, of course, the drum is empty, so the real question is, what's it going to be like with the tickets in it? Stan let me know that a roll of tickets is about 2 pounds, so I don't have any paper in my house. I'm not a paper kind of person. So I tried to find some other stuff that I could add up to 2 pounds that was also kind of soft, which turns out to be difficult to do. So I found some gloves and some towels and a little bit of Delrin and some leather scraps. I wrapped the leather around the Delrin so the Delrin doesn't ding up the drum, and I just threw it all in there and tried to make up 2 pounds of simulated mass here. And I'm just gonna throw the roll of tape in there too. And the string, that's soft, that's pretty heavy. All right, we'll throw that in there too. Now, Stan said the maximum weight is gonna be 6 pounds. That's 3 full rolls of tickets. So we will see how it does with one here first. I'm running it on about 15 PSI of pressure here. And you can see how it's struggling to get the drum going because of how off-center the mass is. And the way the mass flops around, it causes the drum to get stalled and causes the belt to slip. So additional belt tension certainly helps, but this is certainly kind of problematic. Now, this test isn't very good though, because fluffy paper tickets don't fall quite so dramatically as a bunch of really heavy, dense items like gloves and towels. So I think what I'm going to do is proceed, and we'll see how it goes at the show. If nothing else, I can get a gimmicky run out of it with some of the tickets in it, and we'll go from there. So I threw a coat of paint on the base to make it look 8% less like garbage, and using whatever color I found. This is something called soft iron. I don't know, whatever. But wait a minute, before we go to the show, I promised you live steam. So let's do a little dry run here, so to speak. I guess it's a wet run on live steam. So I set up the electric boiler and I steamed it up to 25 PSI, give or take, and blew out the O-ring. Yeah, the O-rings that I use on that fill plug are not steam rated because I bought the wrong ones, so I've just been using them up. So I replaced that O-ring. I usually get 1 or 2 steamings out of each one, and then it was fine. And let's give it a run. We just got to push the water through, and there it goes. Look at that, running the ticket drum on live steam. That's pretty awesome. So I'm very pleased with that. It looks like it's going to do at least this as an exhibition at the bash. But we shall see how it does with actual tickets in the drum. Okay, enough fooling around. Boxed it all up, took it to the bash, and let's see how it does with tickets in it. Here is the first run. We're running on air here, and that's not too bad. You can see as the emceeing went along, we gradually added more and more tickets as people bought tickets, and you can see the drum's getting pretty full there, and it's running it very well. So luckily the tickets, the way that they fall in the drum, they're much fluffier and more forgiving than my gloves and towels test. Now, it was my turn to MC. You're seeing footage of the live stream here, and thankfully my good friend James there was carrying the MC burden because I was trying to MC and help with the raffle and get the boiler up and running all at the same time, because I promised the crowd a raffle drum running on live steam, not compressed air. So you can see me frantically trying to get the boiler going. I had a lot of technical difficulties with it because of the setting here. I blew the O-ring again, and well, here, I'm going to explain here a little bit.
How are we doing, Quinn?
Some technical difficulties. The boiler has never been run in public or in this kind of heat.
Oh, okay.
So we're having some challenges with it here.
You want to talk us through the challenges?
Well, so first of all, the fill plug has an O-ring on it that's not steam rated, so it's given out on me.
Okay.
Usually I get away with it, but not this time.
and it's running the pressure up too high, so I shut it down, and I'm not sure why. The thermostat got jostled in transit, I think.
Okay.
And so I'm trying to figure out, the calibration on it got lost, so I'm trying to basically recalibrate it here.
Okay, so it's not certified for transportation use.
Exactly, yeah.
Okay.
So,
But with some quick thinking and some improvising, I got a little bit of cooperation out of the boiler. So moment of truth time.
Okay, we got some action over here on the boiler. I don't know if I should be excited or if I should stand back. And there it goes. Running on live steam and water. Is this what we call wet steam?
So when it first starts, the engine is cold, and so the steam condenses, so it makes a bunch of water. All right, I promised you raffle drum on live steam. This is it.
There you go.
All right. Excellent.
Nothing like live steam. You can run on compressed air, and it's a cool toy, but live steam is real power. It's going to make your ticket wet, which I don't know how that's going to affect your chances. So there's no water pump on this, so we only get a couple of minutes of running before the boiler is empty. So enjoy it while it lasts.
So do you still have you got a drain valve there on the cylinder, or does this just push through the exhaust?
So small engines like this do not have drains on the cylinders, so that you just push the water through. But yeah, on a larger engine, when you first run them, you got to open the valves on the cylinder so the water can get pushed out and you don't hydrolock the engine. But on a small engine like this, it just pushes the water past the rings. It's fine. So we're running out of steam, literally.
Oh, that's still amazing.
I lost a bunch of water getting it working, so unfortunately we're not going to get much of a show here.
I think your steam lubricated belt there is slipping as well. But
Yeah, the string is not up to this job.
it's still fantastic.
Well, there you go. That was a lot of fun. I really enjoyed giving that a shot, trying to run the raffle drum on live steam. The little engine ran great all day, mostly on compressed air and a little bit on steam, as you saw. So thanks to Stan for putting on the Barzy Bash every year. It's a great event, and I love talking to all the fans that come, and thank you to all of you who said hi and said nice things about the channel. Really appreciate it. Thank you very much for watching, and I will see you next time.
So enjoy it while it lasts.